All right, let's get right into it. Today, we're diving deep into one of the biggest questions you can ask, and we're going to do it through the eyes of the legendary and, let's be honest, pretty controversial physicist Roger Penrose. The question is this: is your mind just a really, really good computer, or is there something else going on entirely? I mean, look around. We're in this age of absolutely mind-blowing AI, right? So this question, it's not just some abstract philosophical thing anymore. We've got AI that can write poetry, that can code better than some humans, but Roger Penrose says there's a hard line in the sand, a fundamental barrier they can never cross. And that's the line between just mimicking thought and having genuine, actual conscious understanding.
And this really sets up the whole debate perfectly. So on one side, you've got the best AI we can build today. And what's interesting is that even a recent research paper from Apple pointed out that these things hit a scaling wall. At the end of the day, what they're doing is just incredibly sophisticated pattern matching. But then on the other side, you have what Penrose is really interested in, that's human understanding. It's about insight, awareness, the ability to grasp truths that go way beyond just following a set of rules.
Okay, so to build his case, Penrose takes us on this kind of intellectual detective story. And the first clue, well, it's in a place you might not expect. We're not starting in physics, we're not starting in biology. Nope. We're starting in the pure, abstract world of mathematical logic.
So, first, we've got to get our heads around this idea of a formal system. The easiest way to think about it is like a computer's entire universe. It's a closed world of logic. It's got its starting assumptions, those are the axioms, and then it has a very strict set of rules for how to combine those axioms to prove new things. That's it. It's a completely self-contained, logical box.
And this is where the absolute genius of Kurt Gödel blows everything wide open. See, he came up with a mathematical statement that, in plain English, says, this statement cannot be proven by this system. Now just follow the logic here for a second. What if that statement was false? Well, if it was false, that would mean the system could prove it. But wait, a logical system isn't supposed to prove false things. That would make the whole system inconsistent, a total contradiction. So the only way out of that paradox is that the statement has to be true. And here's the real mind-bender. If it's true, that means the system really can't prove it, just like it says. The system itself is blind to this truth. But we can see it. We can stand outside the box and see that it's true.
And that right there is the crucial point for Penrose. Think about it. We didn't follow the system's rules to figure that out. No, we had to step outside the system, look at the whole thing, and use, well, understanding, insight. And Penrose says that act, that leap of insight, is something a computer, a formal system, just can't do. It's fundamentally non-computational. Okay, great. So human understanding is non-computational. But Penrose is a physicist, right? He doesn't believe in magic. This ability has to come from somewhere. It has to be grounded in the actual physical laws of our universe. So that leads us to the second clue in our detective story. Where in all of physics could a non-computable process be hiding?
Well, first he looks at classical physics. You know, Newton's laws, Einstein's relativity, the stuff that governs the big, everyday world, from throwing a baseball to the orbit of a planet. And the thing is, all of that is pretty much computable. We can stick those equations into a computer and get incredibly accurate predictions. So the secret's probably not there. Which leaves us with the really, really weird world of quantum mechanics.
See, quantum mechanics has this kind of split personality. On the one hand, you have the famous Schrödinger equation. And that part is smooth, it's predictable, and it's totally computable. It just describes how all the possibilities evolve over time. But the real world isn't just a smear of possibilities, is it? Things actually happen. A particle is here, not everywhere at once. And that's the second part, the mysterious collapse of the wave function. It's this sudden, unpredictable jump from all those possibilities into one single, concrete reality.
And for Penrose, this is the smoking gun. He basically argues that the standard explanation for this collapse isn't really physics at all. He famously calls it a double cheat. He says it's just a mathematical trick, a recipe that we use because it gives us the right answers, but it tells us absolutely nothing about what is physically happening. He's convinced that there's a deeper, undiscovered law of physics that governs this collapse, and that is where the universe's non-computability is hidden.
So, if this mysterious, non-computable quantum process is the secret sauce for consciousness, our investigation has to take a sharp turn. We have to go from the grand scale of the cosmos right down into the squishy matter of the brain.
And this, folks, is the million-dollar question. The human brain is, well, it's warm, it's wet, it's a noisy, chaotic mess. On the surface, it seems like the absolute worst place in the universe to try and maintain the delicate quantum states needed for something like this. So, where on earth could it possibly be happening?
Well, the first place you might look is the standard way neurons fire, those electrical spikes zapping around. But Penrose pretty much rules that out immediately. They're just too classical. They're big, noisy, predictable electrical events. You can literally describe them with computable equations. This is not the place you're going to find the kind of delicate, fragile quantum coherence you'd need.
So, he needed a new suspect. And working with an anesthesiologist named Stuart Hameroff, they landed on one: microtubules. Now, what are these? They're these tiny, tiny protein cylinders that basically act as the skeleton inside our cells, especially inside our neurons. And Hameroff's big idea was that maybe, just maybe, these are the perfect little quantum sanctuaries. They could be the structures that are able to shield and host these super delicate quantum processes that Penrose was hunting for.
Okay, so let's recap our detective work. We've got our first clue from pure logic, we've got our second from a deep mystery in physics, and now we have a biological suspect. We have all the pieces on the table. So let's put them together and see what the final picture, Penrose's full theory, actually looks like. Here's the chain of reasoning, step by step. 1. Gödel's logic strongly suggests that human understanding is non-computational. 2. That non-computational power has to have a physical source, and the best candidate is that mysterious collapse of the wave function. 3. The most likely place in the warm, wet brain for this quantum process to happen is inside those microtubules in our neurons. And 4. The grand conclusion. Penrose proposes that this entire physical chain is consciousness. It's the physical basis for our subjective experience.
Now, you might be thinking, okay, this is all pretty wild and abstract, but this theory might actually help explain some really bizarre experimental results. I'm talking about the famous Libet experiments from decades ago. What Libet found was that the brain activity for a decision, like lifting your finger, actually starts before you're consciously aware of even making the decision. It's like your brain acts, and then your conscious mind is told about it a split second later. So weird.
And in our normal, everyday classical world, that makes no sense. Time marches forward, cause comes before effect, period. But quantum mechanics, it doesn't play by those rules. It has a super bizarre relationship with time, allowing for effects that seem to defy our normal intuition. So Penrose suggests, what if our consciousness isn't operating on classical time? What if it's somehow tied into this quantum reality? That could potentially provide a framework for explaining those weird, almost backwards in time results that Libet found.
And all of this leaves us with one final, absolutely profound thought to chew on. If Penrose is even close to being right, it means your mind, your consciousness, isn't just some complicated software running on the hardware of your brain. It means your mind is tapping into a fundamental, non-computable layer of reality itself, a layer that a purely computational AI, by its very definition, could never ever reach.